Hi middle one, our lesson today is about geometric transformation. We have three types of geometric transformation: reflection, translation, rotation. Reflection, translation, rotation. Before talking about the reflection, let's revise the meaning of line of symmetry. Line of symmetry divided the figure into two congruent figures, such that if we fold the figure, it seems to be just one figure. About the axis of symmetry of the special polygons, parallelogram and trapezium has no axis of symmetry. Isosceles triangle and isosceles trapezium has one line of symmetry. Rectangle and rhombus has two axes of symmetry. Equilateral triangle has three axes of symmetry. Square has four axes of symmetry, and any regular polygon has number of axes of symmetry equal to number of its sides. Now let's talk more about reflection. We have two types of reflection: reflection in a straight line and reflection in a point. About the reflection in a straight line, to have an image of a figure by reflection in a straight line, we can find the image of all of its vertices by drawing a perpendicular line to the axis of symmetry and plot the point of the image at an equal distance, like the distance between the original point and the axis of symmetry. About the reflection in the Cartesian plane, we notice that if the original point, its ordered pair is x and y, its image by reflection in x-axis is x and negative y, while the reflected point in y-axis, if the original point x and y, the ordered pair of its image in y-axis is negative x and y. About the properties of reflection in a straight line, reflection in a straight line reserves the length of the line segments, the measure of the angles, the parallelism, and the betweenness. But reflection in a straight line does not reserve the orientation of the vertices of the figure. And about the reflection in a point, we can find an image by reflection in a point by joining the original point with this point and extend this line and plot the point of the image at an equal distance, like the distance between the original point and the point of reflection. And about the reflection in a point in the Cartesian plane, we notice that the image of any point by reflection in the origin point, if the ordered pair of the original point is x and y, the image by reflection in the origin point is negative x and negative y. Properties of reflection in a point. Reflection in a point reserves the length of the line segments, the measure of the angles, the parallelism, the orientation of the vertices of the figure, and the betweenness. The summary of the types of reflection in the Cartesian plane: reflection about the x-axis, if the original point x and y, its reflected point x and negative y. Reflection about y-axis, the original point x and y, its reflected point negative x and y. Reflection about the origin point, if the original point x and y, its reflected point negative x and negative y. Now let's talk about the second type of geometric transformation, which is translation. The equivalent word for translation is slide. In this example, here each vertex slides 6 units in the right direction of x. To have an image by translation, we should have a magnitude and direction. In this example, the figure moved 4 units in the positive direction of xx and moved 5 units in the negative direction of yx. Properties of translation. Translation reserves the length of the line segment, the measure of the angles, the parallelism, the orientation of the vertices of the figure, and the betweens. And now let's talk about rotation. Rotation like turn around a point. Now let's talk about degrees of rotation. In the first figure, turn it 90 degrees counterclockwise. The original point A1 and 2, turn it to -2 and 1. Second figure, turn it 180 degrees counterclockwise. The original point A1 and 2, turn it to -1 and -2, and the third figure, turn it to 170 counterclockwise. The original point A1 and 2, turn it to 2 and -1. From the previous, we noted that rotation 90 degrees counterclockwise if the original point x and y, the rotated point -y and x, by rotation 90 degrees counterclockwise. While by rotation 90 degrees clockwise, which equivalent to -90 degrees, if the original point x and y, the rotated point y and -x, as shown in the figure. Now let's say that rotation 90 degrees counterclockwise, the same rotation 270 degrees clockwise, which is -270 degrees, gives me the image by rotation -y and x, while rotation 100 degrees counterclockwise, the same rotation 180 degrees clockwise, which is -180 degrees, gives me image -x and -y, and rotation 270 degrees counterclockwise, the same rotation 90 degrees clockwise, which is -90, gives me image y and -x. Summary of rotation in the Cartesian plane. Rotation 90 degrees counterclockwise, the same rotation 270 degrees clockwise, which is -270. The image of the point x and y is -y and x. Rotation 180 degrees clockwise or counterclockwise, positive or negative 180 degrees, gives me an image to the point x and y, -x and -y, while rotation 90 degrees clockwise, which is -90, the same rotation 270 degrees counterclockwise gives me an image to the point x and y to be y and -x. Properties of rotation. Rotation reserves the length of the line segment, the measures of the angles, the parallelism, the orientation of the vertices of the figure, and the betweens. Thanks for listening, and we're gonna meet in other lessons.